Mercury is always close to the sun, and so um, it's up high in the sky when the sun's up, and high in the sky is when you get the best view, and so that makes it a very difficult thing to actually see. When you see it in the twilight, that means it's low to the sky, and so that means it's not as easy to see. So most pictures of Mercury are pretty unsatisfying because we never get a very good view of it. This is actually the best view of Mercury that I have ever seen taken by ground-based telescopes. And this was obviously a professional observatory. They were using every strategy to take a good picture of Mercury. They actually were taking a picture. Actually, I think it was in the daytime when it was high in the sky. They were trying to filter out as much of the light as they could. They were using adaptive optics. They were using everything that they could possibly do to get a good view. And so there we have Mercury. Okay, and so that's about the best view. Well, that's still not all that great. And so to get a really good view of Mercury, you need to go up close. And they actually did that. In the early days of space exploration, they started the idea of sending spacecraft to other planets. So sent something to the moon. The United States sent something to Venus. That was our first interplanetary mission. Then we sent some things to Mars. Well, there was a series of spacecraft called Mariners, which were these octagonal sort of crude spacecraft. A variant of the Mariner was actually used. The Mariner body was used for the Ranger spacecraft that plowed into the moon in the 1960s. The Mariners were sent to Venus and to Mars. Well, there was a whole bunch of them. The Mariner 9 went to Mars, and it was actually very successful. Well, Mariner 10, the body of Mariner 10 was available because they did not need another one to go to Mars, and so they said, why don't we try sending it to Mercury? And so they did. And now what you see here is on this image here, the diagram here, that's a heat shield right there. The idea being you're going so close to the sun that you need to protect the spacecraft. So they had to put a heat shield on it, basically a big parasol. So if the spacecraft were tilted the wrong way and the sunlight directly hit the spacecraft, it would fry the electronics. And so you had to be very careful how you flew past the sun. So Mariner 10 was launched in 1973 to go to Mercury. Now, the problem was we did not have a rocket big enough to slow it down from Earth's orbit to get it all the way from Earth's orbit down to Mercury. So what we did was we aimed at Venus. Venus is pretty close to it. In fact, Venus is closer to us than Mars. Venus is the closest thing other than the moon. Regularly, we do have asteroids that come close, but Venus as a regular planet is closer than anything but Mars and anything but the moon. So it's closer than Mars. So they aimed the spacecraft to pass just in front of Venus. That means Venus's gravity pulled on the spacecraft and pulled it into an orbit that would get down close to Mercury's orbit. And so it flew by Mercury 3 times in 1974 and 1975. This is called the slingshot maneuver, or technically the technical term is the gravity assist maneuver. But slingshot is the popular name for it, in that we aimed at one planet and let that planet's gravity toss the spacecraft on to some other planet. That way you don't need as big of a rocket, and so you can put more into the spacecraft. And so that's how we got to Mercury with Mariner 10. I collect stamps, and actually there was a stamp issued in 1975 in honor of Mariner 10. So that's actually a scan of one of my stamps right there. I collect first day of issue stamps. So up close, Mariner 10 sent back pictures of Mercury, and we say, wow, okay, so Mercury does look kind of like the moon. There are craters there. In fact, there's quite a lot of craters there. Well, there are some differences between Mercury and the Moon. So several significant differences. One is when you look at the Moon, yeah, you see a lot of craters, but you also have seas. When you look at Mercury, you don't see the dark seas. The other thing is in the seas on the Moon, there's very few craters, meaning that they are younger than the other parts of the Moon. On the highlands, you have craters on top of craters. On Mercury, there's actually fewer craters. There's actually space between the craters. And so why would that be? Well, that is because Mercury is actually close to the sun, and a lot of the meteorites that run into the moon are actually asteroids that originate in the asteroid belt. So that means Mercury is farther from the source of all these things. Okay, so here, close up of the moon here on the left, and you can see crater upon crater, whereas on Mercury, there's actually space between the big craters. And we call those the intercrater plains. So the intercrater plains are the spaces between the craters. There are lots of craters on Mercury too, of course, and there are a lot of those small craters that are in the intercrater plains, but it does indicate there is a difference between Mercury and the Moon, at least in that. Craters all have names. All the craters on the Moon are named after people who've made contributions to the sciences. So most of them are named after scientists. So you have craters named Descartes, you have crater named Copernicus, crater named Kepler, and so forth. You also have craters on the Moon named after astronauts or cosmonauts who died in the line of duty. So the astronauts that died in Apollo 1, they got craters named after them. The astronauts that died in the Challenger accident and the Columbia accident are going to have craters named after them. The rules for naming craters on Mercury is that the craters are going to be named after people who made contributions to the arts and humanities. And so there's a Beethoven, there's a Bach, there's a Tchaikovsky, there's a Shakespeare, there's a Tolstoy, there's a variety of craters named after people who've made contributions to the arts and humanities. There is one exception to that, and that is there's a crater Kuiper, which is one of the brightest craters on Mercury with huge rays streaming out from it. That crater was named after Gerald Kuiper, who was the imaging scientist for the Maritime mission. He'd worked for NASA for a long time, and he died of a heart attack not long before Mariner 10 arrived at Mercury, and so they named the brightest crater they saw there after him. All the rest of them are named after that. There's some smooth plains on Mercury that are very similar to the seas on the Moon. They're named after Mercury in different languages. Remember, a lot of languages, a lot of cultures saw this bright dot in the sky, the planet Mercury, and they named it something. And so those plains are named after Mercury in different languages and cultures. And there's some ridges, or what we call scarps, that are named after ships of discovery. So there's rules for naming everything in the solar system. And these are the rules for naming things on Mercury. So there's a picture of crater Kuiper right there. That one really bright crater right there. So, Mariner 10, as it flew by 3 times, but it flew by every 176 days. Now, 176 days is exactly 2 Mercury orbits. So that means that every time it flew by, the same side of Mercury was facing the sun. And so it saw only the side facing the sun, and so we only saw half the planet. In fact, it didn't even see the entire half of the planet, so there's like a big gap here that it missed. So we actually only saw about 40% of the surface of the planet. With that, we're still able to tell a few things about Mercury. It has an albedo of 0.12. That means it reflects about 12% of the light that hits it. And it's pretty small. It's about 18 times smaller than Earth. But here's the interesting thing. It's also 18 times less mass than Earth. So Earth is 18 times the volume and 18 times the mass. This is not like the Moon, where the the size of the Earth and the mass of the Earth are different ratios with respect to the Moon. This suggests that Mercury has a very similar density to the density of Earth.